mathematicians, welcome. I'm so glad you guys are joining me here today. So we're going to be doing a math mini lesson. This mini lesson is going to have 3 parts. We're going to start with a number talk, then we're going to move on to our focus of the day and practice those skills that are connected to what you'll find on the choice board. And we're going to end with a little bit of review. So we're going to go ahead and jump right in so that our time is used appropriately. I'm going to share my document camera with you, and on the document camera, you guys are going to find our number talk of the day. Now, our number talk, if you've ever had math with me before, a number talk is a time that we are focused on the process. We're focused on our strategies, our thinking. We don't care so much about the actual answer. We care about our process of getting there and the way that our brain is approaching that problem, because our brains are incredible. So I'm going to give you guys 3 subtraction sentences today, and I'm going to give you some time to figure them out. I'm going to draw this one as a better 2 for you guys. Okay, now use your time, use whatever strategies you feel most comfortable with, and find differences and get ready to share your thinking. Okay, friends, now I know I would normally give you guys more thinking time, but since we're on a video, you guys can easily hit the pause button and give yourself more time. So I'm going to ask you to do that. If you'd like more time to work on this math thinking, pause and keep playing once you're ready to see if your thinking matches up with mine or something completely awesome and different. So I'm going to go ahead and start talking about how I might approach these subtraction sentences, and I'm going to show you 2 strategies for each one. Now, with addition and subtraction, we have a whole toolbox of strategies. We have our counters, we have number lines that we can use, we have number charts we can use rec and recs, we can use facts we know, like doubles or ways to make 10. So I'm going to move to a different color so it's easy to see. So for 10, take away 6. A really simple way to figure this one out would be just by drawing 10 pieces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and taking away 6 of them. Now I know this row is 5, and 1 more, that's going to leave me 4. So my drawing strategy would leave me with 4, but I know my ways to make 10, and I know that 6 and 4, it's really hoping for a darker marker here. Let's just go back to black, that's fine. I know that 6 plus 4 is a way to make 10, and I also know that addition and subtraction are related. So if 6 and 4 is a way to make 10, then knowing that my fact family of 10, 6, and 4, 10 minus 4 is going to, 10 minus 6 is going to leave me with 4. So I showed that 2 ways, drawing and also using facts I know. Okay, moving on to 12 minus 6. Now 12 minus 6 could be a good one for counting backwards. If I put 12 in my head and I count back 6, that's 11, 10, 9, 8, 7, 6. That leaves me with 4 left. Oh, sorry, I did not do that right. So start at 12, count back 6, 11, 10, 9, 8, 7, 6. There we go. Sorry, friends. 6 are left. So 12 minus 6 is 6, but that's another one for me that would be using facts I know, because I'm just going to go F-I-K for facts I know. I know that 6 plus 6 equals 12. So because I know that 12 minus 6 is 6. Okay, now moving on to the last one, 22 minus 10. Sometimes when we get to numbers that have 2 digits, we start to get a little bit nervous, and that's okay, but you have all the tools to figure that out. So 22 minus 10. I could do that easily by drawing place value pieces. I could do 2 tens and 2 ones, take away one of those tens, and that leaves me with 1 10 and 2 ones are 12. Or I could pull out my handy dandy 120 chart. Here's 22. And I know that anytime I go up or down on this chart, I'm adding or taking away 10. So 22 plus 10 would take me to 32, but in this case, I'm actually taking away. So 22 minus 10, I need to go up. I need to take away 10, and that takes me to 12. So for this, I showed place value, but I also used the number chart. Now, did the ways that I use line up with yours? Maybe, maybe not, and that's okay. That's what's so great about our brains, is that there are so many different ways that we can solve problems because our brains prefer different ways, and that's awesome. So, moving right along, we're gonna head to our focus for the day. So if you look right behind me on my whiteboard here, this is our objective of the day. I can combine or put together two-dimensional, 2D shapes to create composite shapes. So we're going to review the 2D shapes that we see a lot in first grade. I get it all ready before I screen share for you guys. All right. Share. There we go. Okay, so a little too big. Okay, friends, I'm going to go ahead and read you the names of these shapes, and then I'm going to give you a little time to see if you can sort them with your eyes. So our first word is triangle, triangle, square, square, trapezoid, trapezoid, rhombus, rhombus. That's a silent H right there, just like Miss Watson was telling us about, rhombus. Hexagon, hexagon, and other, which is where we'd put a shape that didn't fit in one of the other categories. So go ahead with your eyes, see if you can figure out where these shapes belong with what shape name. Okay, friends, go ahead and pause if you'd like a little bit more time. Now I'm going to go ahead and dissect these words a little bit, and we're going to sort them and talk about their defining characteristics. So let's start with triangle. Now tri, just like a triceratops has 3 horns and a tricycle has 3 wheels, a triangle has 3 angles and 3 sides. So the only shape on here that has 3 angles and angles are what we're going to call our corners or our vertices. 3 angles and 3 sides, that is our triangle. So the defining characteristics of a triangle is that it has 3 flat sides and 3 corners or vertices. We could say corners, but we're mathematicians, so we're going to say vertices because that's just cooler. All right, moving right along. We have this blend, square, square. Now that's a pretty common shape. We spend a lot of time talking about triangles and squares in kindergarten. So a square is a shape that has 4 equal flat lines. So they have to be the same length. They can't be shorter or longer than any other sides, or it's not going to be a square anymore. So a square has 4 sides that are all the same, and it also has 4 corners or vertices. So 4 sides, 4, I'm going to write vert for short. All right, the next one is a trapezoid. Now, a trapezoid can be one of the harder ones to remember. So I tell this little story. This is a trapezoid. I tell this story because a trapezoid has a little short side at the top, kind of like a trap door if you were trying to trap someone, a long side at the bottom, like the bottom of a big pit, and then two lines that are going to connect it. We're going to call that our wall. So tell this little story. The little dude is walking along, then all of a sudden he falls through the trapdoor that's made of leaves or something very light and flimsy. He falls to the bottom and he has to call for help because he has fallen in the trapezoid. Short side, long side, two connecting sides, trapezoid. So together that makes 4 sides and 4 vertices, okay? Next, we have the rhombus. And a rhombus also has 4 sides and 4 vertices, but the trick about the rhombus is that 2 sides have to go in a straight line next to each other, and the other 2 sides have to be in a straight line next to each other. They call that, or we call that, parallel. When 2 lines are lined up with the exact same distance in between them, and 2 more lines, parallel. So these 2 are the same, and these 2 are the same. Blue matches that, and also tan matches that. 4 sides and 4 vertices. Okay, and last but not least is hexagon. Hexagon. And once we start talking about pentagons, hexagons, heptagons, octagons, nonagons, it gets a little tricky with all those agons. So a good way to remember is hex means 6. And there are not too many words in the English language that have X in them, but hex and 6, 6 are 2 of them. So remembering that hex shares an X with 6 is a good way to remember that a hexagon has 6 sides and looks like that. These sides are going to be the same length. So 1, 2, 3, 4, 5, 6. 6 sides that are all the same length and also 6 vertices. You guys starting to see a pattern? Same number of vertices, same number of sides. So we have our hexagons there. Okay, if I were going to sort those attributes, and I said, okay, friends, can you help me find a shape that is, or that has 4 sides and 4 corners, or vertices, because we're mathematicians? What would you say? What was that? Did you say square? I think you did. Square has 4 sides or 4 vertices. That's not the only answer that could fit there, so if you said something else, that's okay. What about 6 sides and 6 corners? Which shape is going to match those defining characteristics? That would be a hexagon, 6 hex. What about another one that has 4 sides and 4 corners? Sure, it could be trapezoid. What about 3 sides and 3 corners? Triangle, triceratops, tricycle, 3 sides, 3 corners, and rhombuses also have 4 sides and 4 corners. So now these 6 shapes also have one more. What am I missing here? Ah, my square. Where'd it go? Ah, here it is. These 6 different shapes also share something else. They share that they all fall in the category of, I'm going to go for a different color. And I'm going to have you read this to yourself. So this is a 3-syllable word. I'm going to show you where the syllables are going to break. 1, 2, and 3. And this is a super sneaky Y who stole the sound from long E for this word. So read the first syllable. Paul, super sneaky Y, E, last syllable, G, on, gone. Polygon, say it with me. Polygon. A polygon is a super sneaky Y, or sorry, silent magic E. Reaches over, makes the O say its name. Close, and I'm going to finish with a D, closed. A closed shape, which means it has to be connected all the way around. The sides have to be connected with the vertices. A shape that is open, looks like that, is not a polygon. That is a weirdo shape, and it does not belong here. So it has to be a closed shape that has at least 3 flat, not curved, has to be a flat or straight side and connects at corners, or what's our 3rd grade word? Vertices, vertices. A polygon is a closed shape that has at least 3 flat sides and connects at vertices. Can you read the definition with me, please? Ready? And read. A polygon is a closed shape that has at least 3 flat sides and connects at vertices. Nice job. Read it one more time to yourself and lock it in. Super job. So these are all polygons because they are all closed shapes. They don't have any open spaces on them. They're closed shapes. They all have at least 3 sides that are flat, not curved, and they connect at vertices. And since it's at least 3 sides, they're going to have at least 3 vertices because we have that connected pattern there. So we're going to take these polygons and we're going to be making some composite shapes today. So in the objective, I told you guys that we're taking 2-dimensional shapes and we're putting them together to create composite shapes today. So here is an example of a composite shape. Now, just right off the bat, you probably see a square. You probably see a trapezoid, and you probably see 2 rhombuses. I see those things too. But another thing I could see is a hexagon, a triangle, and a square. Now, both of these are composite shapes that share the same outline, but they're created 2 different ways. Okay, let's try one more. Check out this guy. Now try and look past what we see, what those colors, and imagine another way that we might be able to make that composite shape. I have a few ideas in my mind right now, but I'm going to try a hexagon here, a hexagon here, and then that leaves 2 spaces right here to fill those in. So I have 2 composite shapes, same outline, but created with 2 different kinds or 2 different combinations of 2-dimensional shapes. So now I have a challenge for you guys. So here's my hexagon. My challenge is how many of these, remember they're called trapezoids. How many trapezoids do you think it takes to create a composite hexagon? Is your brain trying to break it apart right now? Your brains are so cool. Okay, so if you'd like more think time, go ahead and pause. But a trapezoid, if I put it right on top of my hexagon, it's going to create, or it's going to fill half of that shape. 1/2 of a hexagon is a trapezoid. And look at that shape down there. That looks familiar. Yeah, another trapezoid is going to fit perfectly on that hexagon. So it takes 2 trapezoids to make a hexagon. 2 halves of trapezoids make a whole hexagon. How many rhombuses do you think we need to create a composite hexagon? Okay, friends, if you'd like a little more think time, go ahead and pause. but I'm going to take one rhombus and line it up right here. Now, let's see, it's a little bit more than half that I have left to fill, so it can't be 2, but it might be 3 or 4. Let's try one more and see. Okay, so that fills in 1, 2, 3 parts. So maybe these are thirds. Let's see. Oh, so it takes 3 rhombuses to make one whole hexagon. So these are actually thirds. So I'm going to put a 1 on top of a 3 to show that it's a third. Those are my thirds. Now, how about triangles? How many triangles do you think it takes to create a full hexagon, a composite hexagon? I'm actually going to move the hexagon out of the way and see if we can take a little bit of a detour. So instead of how many hexagons fit or triangles fit in the hexagon, now take your thinking and say how many triangles are going to fill the trapezoid. One, two, 3. Well, if 3 of these make one trapezoid, and it takes 2 trapezoids to make a hexagon, write this down, then so that's 3 triangles, but I know I need 2 of these. So shouldn't it be 3 plus 3? If I have 3 triangles, theoretically that should make a hexagon, right? Let's try it out. Good start. Okay, together that makes about half. Filling in the rest. Get on there. Get on there. Nice. So since there are 6 triangles that make up a hexagon, each one of these we're going to call 1/6 to make up our whole of a hexagon. In your choice board activities, you're going to find an activity on composite shapes where you have to determine what shapes were used to create a composite shape, and the opposite, what composite shape you could create using a combination of 2-dimensional shapes. And you're also going to have a subtraction practice page so you can apply your subtraction strategies. So those are our big skills for the day. But before we leave each other, I'm going to do a little bit of review with us as well. So I know you guys are time experts. Time to the hour, time to the half hour. I like to do the little poem, big hand at the top. It's 3 o'clock. Big hand goes around and it's pointing down. It's 3:30 because we go in that clockwise direction. It's 3:30. It's 3:30. So I'm going to give you guys a challenge. I'm going to pull up my screen sharing again. Here we go. So my challenge is if, and this is a true story, if, focus, there we go. If I have a meeting with Mr. McConnell at a time in the afternoon when my big hand is at the top and it's between the hours of 12 and 2, what time is my meeting with Mr. McConnell? if my big hand is at the top, that's going to have to be up here, my big hand, and my little hand, my hour, I said is between 12 and 2. And because my big hand's straight at the top, I know it's going to have to be pointing at the hour because it's right at o'clock. The only hour between 12 and 2 is 1. So if you guessed that my meeting is at 1 o'clock, you are right. Now my question, friends, is it AM or PM? Well, 1 o'clock in the morning, I don't know about you, but I am sleeping. It is dark outside. The sun hasn't come up yet. It is just an hour past midnight. So my meeting is definitely not at 1 a.m. My meeting is at 1 p.m., right after lunch with Mr. McConnell. Now let's say that meeting lasts about 30 minutes. If it lasts about 30 minutes, can you tell me what time the meeting is over? So plus 30 minutes. Okay, we know that each one of these little notches represents 1 minute, which means a group like that represents 5 minutes. And if I'm counting by fives with my minute hand, 5, 10, 15, 20, 25, 30, plus 30 minutes. My big hand goes around and it's pointing down. It's half past 1. It's 1:30 p.m. Okay, now friends, my meeting's over. I am hungry. I go to the kitchen, I get my lunch, and my dogs, they just want to go for a walk because they love walks. So I have my lunch, I go for a walk, I go back to my computer, and I answer some emails, and I look at some of your awesome work. And that all takes me about 1 hour and 30 minutes. What time am I done with lunch, walk, and emails? I know that 1 hour is a full trip around the clock. It's 60 minutes. So that's going to be 60 minutes plus my 30 minutes to find out how much or what time I am done with all of that. So can you guys help me count by fives for my 60 minutes or my hour? I know it's going to take me all the way around, but it does help me if I practice my counting by fives. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. So that's my hour. I'm right back there. Bacon goes around and it's pointing down. It's 2:30. That's 2:30. But I have another 30 minutes I need to add. So friends, on your own, can you figure out where my hour hand and my minute hand will be in 30 minutes? I could do this 2 ways. I can again count by fives, or I can remember that half an hour is 30 minutes. So I'm just going to be moving right up to the top. I'm going to be finished with my lunch, my walk, and my emails at, big hands at the top, it's 3 o'clock p.m. 3 o'clock p.m. All right, friends, good job with that. Now I'm going to finish today with a challenge for you guys. And I'm not going to give you guys the answer, and I'm not going to tell you how you need to solve it. I'm just going to leave this challenge, and we'll address it next time I see you. So my challenge is this story problem. Please read it to yourself. Okay, so let's pull out our important pieces here. A red ant mound can be up to 24 inches tall and 18 inches wide. I'm going to go ahead and circle the information that I know. It can be 24 inches tall and 18 inches wide. How many inches taller is a mound compared to its width? So my brain really likes to work in pictures. I'm a visual learner. So I'm going to go ahead and draw the mound because I think that's going to help me see it so I can figure out how I want to solve it. I know that it's 24 tall and 18 16 wide. So I'm going to leave you guys with this challenge. How many inches taller is it compared to its width? So my awesome friends, that is my mini lesson for you guys today. I hope you take on my challenge. I hope you built some schema today. And just remember that your hearts are kind, your brains are growing, and that you are in control of yourselves. And I love you all. Can't wait to see you next time. Bye, mathematicians.